Hey professor, this is Rob Hines, and this is my solution to the homework 4 assignment. Okay, so here we have the problem statement for problem 3. I am not going to read the entire problem statement and all the 5 questions that it has because I have a lot to explain with my code in addition to that, but feel free to pause it and check it out. Okay, so first and foremost, here's my code for problem 3. Then I'll go ahead and explain it section by section. So very first segment, very first section, you just have the CLC clear, close all. That just closes everything out, including the command window, etc. The second segment here defines the vectors. X1 is the x-axis, x2 is the y-axis. In the next section, what this sims theta does is it just makes theta our variable, and then what this segment does is it defines the 2D rotation matrix and it displays the matrix in the command window. Then this next section we have here swaps the x and y components. It says h, but it should say y components of the vector. Then this next segment here eliminates the x component and projects the vector onto the y-axis. And the following segment, pretty simply, you see the ones and zeros, it just creates an identity matrix. Then the next segment, what it does is it translates and moves all the points towards the line y equals x. Then this big segment here, basically what this is doing is it just pertains to the visualizations, of the vectors. Then the following segment is just adding labels and general formatting. And that's explanation for problem 3. Then problem 8, this is the problem statement. Once again, feel free to pause it to understand it further. And then this is my code for problem 8 right here, and it continues into here, and then I'll go ahead and explain this. Once again, CLC clear and close all, just close everything out, command window, etc. Then this right here is the augmented matrix. The first 3 columns represent the coefficient matrix A. Then the 4th column is vector B here. Then this section, basically what A does is it extracts the coefficients of the system, and then B extracts the right-hand side of the system. And then we have this segment with this line 11 does, it performs the decomposition with partial pivoting. Then we have line 13, display P. What this does is it just prints P, and P is the permutation matrix, and it prints it in the command window. This next segment, what this if loop does is it's basically what it's saying is if P is in the natural ordering 1, 2, and 3 in this bracket here, no swaps occur. But if it's not, then the swaps are needed. And this next segment determines the number of rows, and then it constructs the augmented matrix, and it implements the forward elimination. Moving on to this next bit of code, what this segment does is it initializes the solution vector, then the back substitution solves for every variable we have. Then the following segment displays the solution via Gaussian elimination. Then this segment uses MATLAB's / operator to apply the Gaussian elimination via partial pivoting. And then the very last segment just optimizes and solves the linear equations. And that is all my code and solutions for problems 3 and problems 8.